What if you could move, speak, or connect with the world, using only your mind? Brain-computer interfaces are unlocking abilities once thought impossible, and the revolution is happening now. In the next few minutes, you'll see how BCIs are restoring lost abilities, reconnecting lives, and redefining what it means to be human. Stay with us to discover the future of mind and machine, and why it matters to you. This was Dennis DeGray's reality, a stark and isolating existence that stretched on for years. It all began after a devastating fall, a moment that irrevocably altered the course of his life, leaving him paralyzed from the neck down. His world shrunk to the four walls of his room. For years, Dennis could only think and feel, a constant stream of consciousness trapped within a body that refused to respond. He was fully aware, yet completely powerless. His body no longer obeyed his mind. The simplest of actions, things most of us take for granted, were utterly beyond his reach. Even sending a simple text, a quick message to a loved one, was an insurmountable obstacle. Communication, the very essence of human connection, was severed. Then, a glimmer of hope appeared on the horizon. Dennis joined a Stanford clinical trial, a pioneering effort pushing the boundaries of medical science. This trial aimed to reconnect his mind to the world, to bridge the gap between his thoughts and his ability to interact with his surroundings. It was a long shot, but it was a chance. Surgeons embarked on a delicate and complex procedure, implanting two tiny devices, each a marvel of engineering. These devices were carefully placed into his brain's motor cortex, the command center for movement, specifically the area that controls hand movement, the very function he had lost. These implants acted as sophisticated eavesdroppers, listening to the electrical activity, the subtle whispers of his brain. They meticulously recorded the patterns in his brain whenever he imagined moving his hand, capturing the neural signature of his intention. Advanced algorithms, intricate mathematical formulas, decoded these signals in real time, translating the complex language of the brain. This allowed his thoughts to be translated into cursor movements on a screen, giving him a virtual hand to manipulate the digital world. And then, Dennis began to type, a moment of profound significance. He was typing not with his hands, which remained still, but with his mind, using the power of thought to communicate. He achieved a record-breaking 8 words per minute, a testament to his determination and the power of the technology. He was regaining the ability to communicate, to connect with loved ones, and to express himself once more. This isn't science fiction. This is happening now, in cutting-edge research labs and hospitals around the world. It's the power of brain-computer interfaces, or BCIs, a revolutionary technology that is transforming lives. For Dennis, it meant agency restored, a reclaiming of his independence and control over his own life. It was a new way to interact with the world, to participate in conversations, and to share his thoughts and ideas. His story shows that the silent language of our brains, the intricate patterns of neural activity, can be translated and given voice, allowing us to unlock the potential hidden within. BCIs are not just about technology, they are about human connection, about empathy, and about empowering individuals. They're about restoring hope, redefining what's possible, and giving a voice to those who have been silenced. Dennis's journey is a spark of light, a beacon of hope in a world where many feel lost and forgotten. It offers a glimpse of a future where millions who have lost connection to the world can regain their ability to communicate and participate. The promise of BCIs is to mend what's broken, to heal what's damaged, and to restore what's been lost. It's about expanding human potential, pushing the boundaries of what we believe is possible, and creating a more inclusive and connected world. His experience is just the beginning, a single step on a path that leads to a future filled with possibilities. It's the dawn of a revolution in how we connect mind and machine, a revolution that promises to transform lives and reshape our understanding of what it means to be human. Imagine a world where your thoughts alone can move objects, control devices, and interact with the digital realm. It sounds like science fiction, but it's rapidly becoming a reality thanks to brain-computer interfaces, or BCIs. How does a thought move a cursor or control a robotic arm with such precision and fluidity? What are the underlying mechanisms that make this incredible technology possible? It all starts with the brain's electrical signals, the fundamental language of our minds. These signals are constantly firing, creating a complex symphony of activity that governs everything we do, think, and feel. Every intention, memory, or movement, no matter how small or grand, is encoded in patterns of neural activity. These patterns are unique to each thought and action, like a distinct fingerprint of the mind. BCIs are ingeniously designed to listen to and interpret this neural language, acting as a translator between the brain and the external world. They decipher the complex code of neural activity, turning thoughts into commands. Non-invasive methods like EEG or electroencephalography use scalp electrodes to pick up broad brain rhythms, capturing the overall electrical activity of the brain from the surface of the head, while invasive implants requiring surgical placement capture signals directly from neurons for greater precision, offering a much clearer and more detailed picture of brain activity. Once signals are detected, regardless of the method used, powerful algorithms decode the noisy data, sifting through the vast amount of information to extract meaningful patterns. These algorithms are constantly searching for patterns that match specific intentions, like moving a hand, speaking a word, or even just thinking about a particular object. Machine learning helps the computer recognize these patterns with increasing accuracy over time, adapting to the unique neural signature of each individual. Simultaneously, users learn to control the BCI through practice and feedback, refining their thoughts and intentions to produce the desired outcome. Over time, the brain adapts to this new form of communication, strengthening the pathways that produce accurate results, a process called neuroplasticity, which is the brain's remarkable ability to reorganize itself by forming new neural connections. The user and the machine form a symbiotic relationship, each learning and adapting to the other, creating a seamless link from mind to digital action, blurring the lines between thought and reality. This bridge bypasses muscles and nerves, offering a new pathway for communication and control, allowing intentions to flow directly into the digital world, unhindered by physical limitations. The result thoughts become actions, instantly translated into commands that can control computers, robotic limbs, and a myriad of other devices. This technology is restoring abilities once lost, offering hope and independence to individuals with paralysis and other neurological conditions. BCIs are more than just tools, they are a fusion of biology and technology, a testament to human ingenuity and the boundless potential of the brain. They're built on the adaptability of the human brain, its capacity to learn, evolve, and forge new connections. They're not just listening, they're actively engaging with the brain. They're learning, evolving, and empowering individuals to overcome limitations and achieve new levels of control. The future of BCIs is a partnership between mind and machine, a collaboration that promises to unlock even greater potential in the years to come. It's a new way to connect with the world, directly from thought to action, opening up possibilities we can only begin to imagine. To truly understand the potential of brain-computer interfaces, or BCIs, we need to delve into the very source of their power. We need to look at the origin of the signals that BCIs interpret and translate. That source is, of course, neurons, the fundamental building blocks of the brain. The brain's astonishing network of 86 billion neurons constantly communicate with each other through rapid-fire electrical spikes, creating a complex and dynamic symphony of activity. These electrical signals are the language of the brain. When you form the intention to move, even before the movement begins, specific neurons located in the motor cortex, the brain's movement control center, begin to fire in highly coordinated patterns, a precise choreography of neural activity. BCIs, in essence, act like conductors of this neural orchestra, using an array of incredibly small microelectrodes to listen in and record these intricate patterns of electrical activity from specific groups of neurons. The resulting data stream is massive, complex, and seemingly chaotic, but sophisticated machine learning algorithms are employed to sift through it all, identifying and isolating the specific signals that reliably match the user's intended actions. During the initial training phase, users are asked to repeatedly imagine specific movements. All the while, the BCI system diligently records the corresponding neural activity, gradually learning to associate specific neural patterns with desired commands, actions like moving a cursor up or down, or directing it to the left or to the right. Over time, the decoding algorithm continuously refines itself, learning to understand and interpret the user's unique neural dialect, their individual brain patterns. Providing feedback to the user is absolutely crucial, because when the system accurately responds to the user's intention, the brain reinforces and strengthens those specific neural pathways involved. This continuous feedback loop gradually makes the BCI control more fluid, natural, and intuitive over extended use. It's important to remember that the BCI isn't actually reading minds. Rather, it's translating the underlying physical basis of intention, converting those neural signals into actionable digital commands. Ultimately, it's a collaborative dance, a synergistic partnership between the human brain and the computer. And the result? Seamless, intuitive control over external devices, offering newfound independence and capabilities for those who need it most. Decoding these complex brain signals is truly the very heart and soul of BCI technology. It's the fundamental process by which thoughts are translated into action, one carefully interpreted neural spike at a time. Restoring movement is just the beginning. BCIs are now tackling speech. At UC Berkeley, researchers are developing a speech neuroprosthesis for people who can't speak due to paralysis. High-density electrode arrays are placed over the brain's speech centers, recording neural activity as participants imagine speaking. Algorithms translate these signals into intended vocal tract movements, then synthesize them into audible speech. This approach aims to restore natural rhythm and intonation, not just spell out words. Early results are remarkable. Intelligible speech reconstructed directly from brain activity. It's about restoring identity and the ability to express emotion, humor, and personality. The Berkeley Breakthrough is a leap toward giving voice back to those who've lost it. When scientists report 60% speech intelligibility, what does it mean? It's not perfect, but it means listeners can understand 60 out of 100 words generated by the BCI. For people with severe paralysis, this is a game changer compared to painstakingly slow communication methods. Even with some unclear words, conversation becomes possible. Listeners can fill in gaps using context. This milestone transforms isolation into meaningful dialogue. 60% is just the start. Technology is improving rapidly. Each percentage point gained means a better quality of life. The path to higher intelligibility is clear and accelerating. It's not just a number, it's restored connection and participation in life. BCIs are breaking barriers, one word at a time. BCIs aren't just for restoration, they could enhance healthy brains too. Memory is a prime target. Our memories shape us, but they're fragile. Researchers have developed memory prostheses that stimulate the hippocampus, the brain's memory center. By recording and reinforcing neural patterns, BCIs can boost recall by up to 300%. This isn't a general brain boost. It's targeted strengthening memory formation. Imagine students learning faster, or older adults maintaining independence. For those with brain injuries or early Alzheimer's, this could preserve identity and connection. Memory enhancement is moving from science fiction to reality. We're on the verge of actively strengthening and preserving memory. BCIs could redefine what it means to remember. Enhancing memory and cognition raises tough ethical questions. If BCIs can triple memory or accelerate learning, who gets access? At first, only the wealthy might afford them, risking a new social divide, the enhanced versus the naturals. The enhanced could outcompete others in every field, creating a biological upper class. Should enhancement be regulated or made universally available? The debate challenges our ideas of fairness and what it means to be human. If many choose enhancement, the baseline for normal could shift, leaving others behind. The promise of BCIs comes with the responsibility to ensure no one is left out. As BCIs rapidly become a reality, mental privacy is increasingly at stake. BCIs can read your brain's most personal data, your intentions, emotions, even unspoken thoughts and feelings. The risk of brain hacking is very real. Malicious actors could disrupt these devices or extract sensitive, private information. Corporations might even use neural data for targeted advertising, carefully measuring your emotional responses. So, who truly owns your brain data, you yourself or the company? Legal frameworks must urgently protect mental privacy and fundamental data rights. Without proper safeguards, we risk a surveillance society that directly invades the mind itself. Protecting our very thoughts is the next crucial frontier of privacy. To harness BCI's benefits and avoid dystopian risks, security and privacy must be foundational. BCIs need robust encryption and neural firewalls to limit data access to only what's necessary. Legal protections should treat neural data as highly sensitive, with strict rules on collection, use, and deletion. Selling or sharing brain data without explicit consent must be prohibited. Transparency from companies and public education are essential. Independent oversight bodies should vet BCI devices for safety and ethics. Trust is key. Users must know their minds are protected. Building this secure future is a global challenge. The goal: empower individuals without compromising rights. The future of BCIs depends on getting security and ethics right from the start. We stand at a turning point. BCIs are becoming extensions of our minds. They promise to restore lost abilities and expand human potential, but also pose risks of inequality and lost privacy. The real choice is how we guide their evolution, with caution, wisdom, and a commitment to human values. Will we build safeguards and ethical frameworks, or let profit and progress lead unchecked? The future of BCIs is not set. It's shaped by our decisions now. We are all stakeholders in this story. The benefits are profound, but so are the risks. What kind of future will we choose to create? The future's moving fast, don't fall behind. Subscribe now and stay one step ahead always.